Alright, and welcome back to my next award-winning maths tutorial. This time it's about numbers with powers, also known as exponents. So when we're talking about numbers with powers or exponents, we're talking about this small number here that's to the top right hand side of the 3. Another example could be 4 to the power of 2, or we could have 10 to the power of 2. So these numbers up here, these smaller numbers, are called a power or an exponent, but we'll talk about that again in a minute. So today our what we are learning to is to solve multiplication problems that have powers or exponents in them. Okay, so let's look at our first example. 3 squared is the same as saying 3 to the power of 2. So 3 squared is basically saying a 3 by 3 grid, and in this 3 by 3 grid we can see that altogether we have 1, 2, 3, 4, 5, 6, 7, 8, 9 squares. So 3 squared equals 9, and we know that's true because 3 times 3 equals 9. So all 3 squared means that it's 3 multiplied by itself. Okay, let's have a look at another example. So now we're looking at our second example, 4 squared. Squared is just the 4 to the power of 2. So 4 squared means 4 times 4. And again, if we look at our grid, we're looking at 1, 2, 3, 4 across, 1, 2, 3, 4 down. So a 4 by 4 grid gives us an answer of 16. So 4 squared, or 4 to the power of 2, is the same as saying 4 times 4, which is 16. Okay, so let's look at another example. This time, instead of squaring it, we're going to cube it. So cube is just saying a number to the power of 3. So what we're saying here when we have 3 to the power of 3 is 3 times 3 times 3. Now to solve this, we need to do the first multiplication equation, then multiply that answer by the next number. So our first multiplication equation is the 3 times 3, which is 9. We then have to times that by 3 again to get our answer of 27. So 3 to the power of 3, or 3 cubed, is 27. Now if Mr. Smith could draw, he could show you a brilliant cubed picture which would confirm that it is 27. So because I can't draw, I got my special guest artist in to draw, and this is their version of a 3 cubed equation. So if we actually looked at this, you would find that there is indeed 27 squares, which is 3 cubed. So what we've got is 3 surfaces, each of 9, which is 3 times 3, and that's how we get our 3 cubed. Now some of you out there in YouTube land might be asking yourselves, why we bother showing equations such as 4 squared or 3 cubed? Well, there's a good answer to that, and it's coming up in about 2 seconds.
I want to do it.
Now the reason why we show an equation like this, or like this, or like this, is it saves space and time. It's quite quicker to do 3 cubed than having to write out 3 times 3 times 3. 4 squared is quicker than saying 4 times 4 and having to write it down. And the same with 10 squared. It's quicker and shorter than having to write 10 times 10. So that's basically why we use it. It's an expression that makes things quicker and simpler. So let's have a look at one final example. 3 to the power of 4 is just the same as saying 3 times 3 times 3 times 3. So 3 times 3 is 9, times 3 times 3. So let's solve the next equation, which is the 9 times 3, that is 27. And we've still got another times 3 to go. And of course here we could use partitioning to work it out, but Mr. Smith's so clever he knows it anyway, and that answer is 81. So 3 to the power of 4 equals 81. So today we've been learning how to multiply problems that involve using powers or exponents. So remember, it is this number here that is the power or the exponent. That tells us how many times we have to multiply the base number here. So for example, when we've got 3 to the power of 4, it's 3 times 3 times 3 times 3.